In this video, I want to talk about the connection between the Poisson distribution and the exponential distribution. So let's suppose we have some type of Poisson process. Let's let t1 be the time the first event occurs. We're then going to let ti be the time between the I minus first and the ith event. So, as an example, let's suppose t1 is equal to 4 and t2 is equal to 7. So that means the first event happened at time 4, whereas the second event happened at time 11. Since the first one happened at time 4 and the second one happened 7 times later, so a total of 11. And these times, t1, t2, t3, etc., are known as interarrival times. So let's suppose x is our Poisson process with a rate of alpha. Then the interarrival times will have an exponential distribution. And the PDF will be given by f of t equal to alpha e to the minus alpha t. So the parameter for our Poisson distribution is the same parameter for our exponential distribution. Let's look at some examples of this. Let's suppose user logons to a college's computer network can be modeled as a Poisson process with a rate of 10 per minute. So that tells me exactly what lambda is, or alpha is, in this process. If the system's administrator begins tracking the number of logins at 10 a.m., we want to find the probability that the first logon recorded occurs between 10 and 20 seconds after that. So this does tell us it's a Poisson process. And since we're looking at the time between processes in a Poisson distribution, that means we're going to be dealing with exponential. Since this unit here is in seconds and this one is in minutes, we need to convert. So I want the probability that we have 10 out of 60, since there are 10 seconds out of a total of 60 seconds in a minute. We want the chance that it's between 10 and 20 seconds. For these continuous distributions, it's much easier to use the CDF. Remember, the CDF was 1 minus e to the minus lambda x. So in this case, you always do the biggest minus the smallest. 1 minus e to the negative 10 times 20 over 60 minus 1 minus e to the negative 10 times 10 over 60. And if we rework this, we get e to the negative 10 times 1 over 6 minus e times negative 10 times 2 over 6, which works out to be 0.1532. So the probability that the first login recorded occurs between 10 and 20 seconds is 0.1532. Let's suppose the lifespan of a car battery averages 6 years. Suppose the battery lifespan follows an exponential distribution, so we do know we're using exponential. We want to find the probability that a randomly selected car battery will last more than 4 years. It's the probability that x is greater than 4. Our cumulative distribution gives us the probability that x is less than 4. So it's much easier to look at 1 minus the probability that x is less than 4. The CDF is given by 1 minus e to the negative lambda x. And if we simplify this, we get e to the negative lambda times 4. So the question is, what is lambda? We do have that the battery averages 6 years. So what we do know is that the mean is 6. And for an exponential distribution, that's 1 over lambda. So lambda is 1 over 6. So up here we have e to the negative 1 over 6 times 4. And this works out to a probability of 0.5134. So there's a little over half of a chance. So there's a little over a 50% chance that this car battery will last for more than 4 years.